for our final actual, like where we're going to work it out example for section 7.2, we're going to look at a case where it starts out ambiguous, and in the end, only one of the triangle possibilities produce an actual triangle. So you'll see if it's going to go wrong, where it's going to go wrong, so that you can start to recognize that. So the first one will work out perfectly, but that second one will have some problems. Okay? All right, so we're going to solve the triangle ABC. If we know that capital A is 43.5 degrees, we know that little a is 10.7 inches, and we know that little c is 7.2 inches. And that's all we're given. In this scenario, we have two sides, and we have the angle opposite one of them, not between them. That is the ambiguous case of the law of sines, and you really need to memorize that. Of all the cases you need to have memorized, that's the one you need to be the most familiar with. The only thing I could possibly solve for right now is what? C. Capital C, right? Okay. Because it's the only one where I know it's opposite. So if we're going to look for capital C, we have to set up a proportion that says 7.2 inches divided by sine of capital C must equal 10.7 inches divided by sine of 43.5. Remember, you have to stack the side over the sine of its opposite angle. We'll cross multiply, and we're going to find sine of capital C. Sine of capital C must equal 7.2 times sine of 43.5 divided by 10.7. So if you work that ratio out, what is sine of C? So it looks like sine of capital C has to equal 0.4631918664. That's its ratio, which is possible. That's between -1 and 1. Because it's possible, we're going to have two possibilities because sine is positive in quadrant 1 and 2. To find the quadrant 1, you simply inverse sine the number you're given. So second sine of that number is 27.6 degrees. That's the first possibility. But there's also the possibility that that could happen over in quadrant 2. If that's the case, then it would equal whatever 180 minus that is, because that's how you find the reference angle. And that was 152.4 degrees. Whoops. Let's finish that. Okay. So that's our second possibility for C. Let's finish up on the left side. Now that we know C1, we can also find capital B1. Because B1 is whatever it will take to make supplementary the other two. So 180 minus 27.6 minus the one we were given, which was 43.5. So it looks like capital B1 must equal what? What was that? 108.5 degrees. That's 108.5 degrees. Okay?
What is it, 9? 5 or 9?
I got 9.
I got 9.
Okay. Well, I just can't write. It is a 9. Let's fix it. Thank you. Is everybody good so far? For this triangle situation, the quadrant 1 over here, and look, it turned out that angle B was in quadrant 2. That's okay. You can have obtuse triangles. There's nothing wrong with getting an angle that's over 90. What are we still missing? Little b? Okay, and since Pythagorean theorem is off limits with oblique triangles, we'll have to do log sines again. B over sine of B must equal the given 10.7 over the sine of its opposite angle. And we'll just cross multiply and solve for B. So in this case, we get 10.7 times the sine of 108.9 divided by the sine of 43.5. Did you guys get 14.70624.834? Yeah. And those are going to be in inches, and looks like we really only have how many significant digits here? I think it's 2, right? Is it 2? Yeah, we only have 2, so about 15 inches. Okay. All right. So that completes triangle 1. Do you guys understand that? Let's go over here and try to finish triangle 2. We already know that C2 is this, so that means that B2 has to equal 180 minus C2 minus A, which is given, and you use that on both of the triangles. What does that produce? Negative 15.9. Can we have a negative angle in a triangle?
No.
No. So this one actually does not exist.
That's what happened on the homework.
That's what'll happen. There's some in the homework that'll happen too. So what you may want to do, if a problem doesn't ask you to actually solve, if it just says find out if there are 0, 1, or 2 possibilities, if you do each steps like one right after another, like find C1, find C2, find B1, find B2, it will keep you from having to work the entire problem. If something's going to go wrong, this is where it's going to go wrong. Or it'll go wrong at the very beginning when we got that error and we knew that there was nothing that could possibly work. Do you guys understand that? Okay. So if the first one works, the second one, if it's going to fail, is going to fail on this third angle right here. Does that make sense? For our final example, we want to put our calculators away. You're not allowed to use them. And we want to examine this problem, and without using law of sines, explain why angle A equals 104, little a is 26.8 meters, and little b is 31.3 meters cannot be valid for a triangle ABC. So here's what we know. This, we'll call this angle A, and we know that it's 104 degrees. Okay, that's what we know so far. We know that little a is 26.8 meters. We will call this angle B, and we know that little b is 31.3 meters. And this will be angle C. And we want to explain how we know that that cannot happen. What has to be true about the longest side of a triangle? It has to be opposite the largest angle. And the smallest side has to be opposite the smallest angle, and so on. Okay, that has to be true for any triangle. All right, in this case, if this angle is 104 degrees, does that have to be the largest angle?
Yes.
It has to be, because I only have 76 degrees left over to split between these two. Does that make sense? So this has to be the largest angle, because it's already obtuse, and you can only have one obtuse angle. That would mean then that this should be the longest side, but this is 31.3. So if I were in that situation, this triangle could not exist ever. So how do we say that? Because angle A is the largest, but little a is smaller than little b. So that's how we know it can't work, right? Little a should be the largest side, and there's no way that that's going to happen here. Make sense? Great. That wraps up section 7.2.